Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. In the previous video, we discussed about the Einstein explanation of photoelectric effect, and also we have solved some problems based on the Einstein photoelectric equation. Today we are going to discuss de-Broglie explanation of dual nature of light. Since radiation has a dual nature, it is possesses properties of both wave and particle, and universe is composed of radiations and matter. Therefore, de Broglie concluded that moving particle must also possesses a dual nature, since nature loves symmetry. According to de Broglie, a moving particle According to de Broglie, moving particles sometimes act as a wave and sometimes act as a particle. The wave associated with a moving particle is called matter wave, and a de Broglie wave whose wavelength called de Broglie wavelength. We are going to derive the de Broglie wavelength here. Let's consider Planck's quantum theory. According to Max Planck, the energy of the incident photon is given by E is equals to h nu, and Einstein mass energy relation, which gives E is equals to mc square. If we equate these two equations, because these two are representing the energies, after equating we will get h nu equal to mc square. For the simplification for mass m, you will get h nu divided by c square. The momentum of the photon is given by momentum equal to mass into velocity. But mass is already we have derived here, that is this one. And velocity means here velocity of the photon. The photon is traveled with the speed of light, therefore I have written here c. If we simplify this, we will get h nu divided by c. If we take this v to the denominator, then the equation becomes h divided by c divided by v. But velocity of the light divided by nu, frequency, which gives h divided by lambda. If you further simplify this equation, you take this lambda to the left side and p, momentum, to the left side, then the equation becomes lambda equal to h divided by p, or h divided by p is nothing but mass into velocity for normal particle. This is the de Broglie wavelength for a material particle. For de Broglie hypothesis, we concluded that if v is equals to 0, then the lambda should be infinity. If v is infinity, then lambda should be 0. It means the wave are associated with a material particle only if they are in motion. The material particle may be charged or uncharged, but when it is in motion, the waves are associated, which are independent of charge. It means de Broglie waves cannot be electromagnetic in nature, because electromagnetic waves are produced by motion of a charged particle. De Broglie wavelength of an electron. Consider an electron of mass m and a charge of an electron is E. Let v be the velocity acquired by the electron when accelerated from the rest through a potential difference of v volt. Then the accelerated kinetic energy of the electron is given by half mv square, where this m is a mass of an electron and v is a velocity of the electron. Then work done on the electron is given by ev, where this v is potential and e is a charge of an electron. Because this both are representing the energy, kinetic energy and potential energy. If you equate this, half mv square equal to ev. If you simplify this equation for the velocity, then after the simplification we get the square root of 2ev divided by m. If lambda is the de Broglie wavelength associated with the electron, then as we have discussed in the previous equation, lambda is equals to h divided by mv. Substitute the value of v from this equation into here. Then we will get h divided by m into square root of 2ev divided by m. If you take this m inside the square root, after the simplification we get h divided by square root of 2mev. If you properly observe, this h is a constant here. The value of h is 6.62 into 10 raised to minus 34 joule seconds, and the mass of an electron is 9.1 into 10 raised to minus 31 kg, and E is a charge of an electron. Charge of an electron is 1.6 into 10 raised to minus 19 coulomb. If you substitute all these values and simplify this, then we will get lambda is equals to 12.27 divided by square root of V angstrom. Thank you for watching my video. Don't forget to like and share and subscribe.